All right, hello everyone, this is Mr. Crozier. I wanted to give you some help on the sine rule proof and formulas here. Well, part one, complete the following formulas. Law of sine. Well, law of sine is about relationships. Everything matches, so side A matches angle A, and you just follow it going down. A, B, and C all matches. Area with triangle with sine. Well, area of a triangle is usually 1/2 the base times the height. I'm just going to call them sides A and B, which works in a right triangle, but in an oblique triangle, it needs to be cosine C, A, B, C. All right, law of cosines. Well, law of cosines reminds me of Pythagorean theorem. A squared plus B squared equals C squared, but then you have to add on minus 2AB cosine C. Again, Pythagorean theorem, extra added on, and look at this. It's A, B, then C. It's A, B, then C. There's patterns everywhere, and C at the front and ending here. Heron's formula for area. Not sure how to remember this one, but we have sine of, or square root of S minus A, S minus B, S minus C. That's what you'll have to write down. A, B, and C are the sides of the triangle. Well, what's S? Well, S is half of the perimeter. You don't have to write that down, but it's good to know that. Whatever the perimeter is of the triangle, the distance around, you take half of it. So if we have a triangle that's, let's see here, 8, 10, and we'll call this 6. What is that, 24? So 24, half of 24, S would equal 12. And then you use 12 in there with the sides. All right, and the main thing of this page is the proof of the law of sine. So, given triangle ABC, well, we want to draw a triangle A, B, and C. There it is, A, B, C. You can label it however you want to, but that's what's given. And we want to prove this rule here, the sine rule. So steps, top to bottom. First step we want to do is say that we have triangle ABC with sides A, B, C. And that is given. Right? We have a triangle. Step number 2, we want to draw an altitude from C to AB with height h. So I'm going to draw this from here to here. Altitude meaning it's straight up, and that's an h. And the reason is that's a construction. That's something you are allowed to do in geometry. You're allowed to draw heights. We don't know what it is. We can't put a number there because we don't know it, but we can draw it. Next, let's do some trigonometry. The sine of A would be the opposite, which is h, over the hypotenuse. And that's just the definition of the sine function. That's what sine means. Sine means opposite over hypotenuse. Well, I can do the same thing with sine of B. Sine of B is h over a. The sine of this one is the opposite over the hypotenuse, which is a, and that's simply the definition of the sine function again. Now your reasonings don't have to be word for word, letter for letter, but it should follow the same pattern, or plan, I guess. All right, and now the next step here is, what can we do with this? Well, the key in a lot of these proofs is to see we have h and h in both of them. They both contain h. So let's solve each one for h. If I multiply this over here, I have h is equal to sine A times b. And this b is not with the a, it's with this whole thing. So it's sine of a times the b. And if I did that down here, and if I multiply this a over here, I'd have h is equal to sine of b times the a. And what did we do? All we did is solve both equations for h. And now that I have them both equal to h, I set them equal to each other. Sine A times B equals sine B times A. That's a transitive property, saying that this is equal to h and this is equal to h, so they're equal to each other. And now hopefully you can see what the next step here. I'm going to divide both sides by sine A and sine B. If I divide this side by sine B, it crosses off, puts the sine B over here. If I divide this side by sine A, crosses off, puts it over there. And what you're left with is B over sine B is equal to A over sine A, because this gets divided over here, this gets divided over here. And that's a sine rule. Write it again, just flip it around in the matching order, and we're going to tack on a C over sine C and say, just repeat the process with an altitude from angle B or A. Like we said at the beginning, you can name your triangle however you want to. If I draw my altitude from B, it's going to be down here. I'm going to have a C in this. And if I draw it from A, I'm going to have a C in it. Same step, same logic. I'm going to be able to do the same process. All right, so this is a proof for the sine rule, top to bottom. Going through, your wording does not have to be letter for letter, but it does need to make sense, and it should follow this order. Unless you can think of something on your own, I would follow this order from top to bottom.